So, okay. I hope my screen is visible.
Yes, sir.
Thanks. So, this problem appeared in GATE 2014 for 1 mark. And in the problem, we had to calculate the torque of the machine when the current of 8 ampere is flowing through the armature of the motor. So, one condition was given at no load, 230 volt of separately excited DC motor when running at 1400 RPM and the armature resistance drop and brush drops are neglected and field current is kept constant at rated value. It means field current will be constant till the rated value. So it will operate in constant flux zone or constant torque zone, we can say. So at no load, V is equal to EB. Why I am saying that? If there would have been some resistance, then the equation would have been like that, EB minus IARA. But since armature resistance is zero and brush drops is also zero, then all the drops are going to be zero and V is going to be equal to EB. Now, so we know at rated speed, EB is equal to V is equal to 230 volt, right? So I come to this conclusion by first statement, right? And now, if I move further, the field current is kept constant, that also we have interpreted. The torque of the motor in Newton meter for armature current of 8 ampere. So what will happen when armature current of 8 ampere will flow? So basically this is the question. Now, to calculate torque, there is a relation between torque and power in terms of a speed. Since we know a speed, we know back EMF. So we should relate what should be the relation between torque and power with respect to a speed. So can anybody tell me what is the relation between torque and power with rated speed or any speed?
Yes, a power is equal to torque into angular velocities.
Perfect. So power is equal to torque into omega. So this formula we will apply and power developed here will be EB into IA. Since IA we have given in the question, EB we have calculated, so we can easily calculate power, right? So power would be equal to 230 into 8 and that will come out to be, let me calculate it, that would come out to be 1840 watt, right? Now we are left with the torque. So it is very simple now. Torque is power by omega and power is 1840. Omega is 2 pi n by 60. Right? N in RPM, 2 pi into RPM by 60. So if we do 1840 by 2 pi, n is how much? N is 1400 RPM by 60. After calculation, it would come out to be, I guess, 12.15.
Yes, sir.
It should come out to be 12.50 Newton meter. So this was very simple problem, but a bit conceptual also at the same time. Like how would you handle when armature resistance is neglected, right? So in that case, you should relate whatever data are given there. So this was all about this problem. Any confusion, doubt in this problem, you can ask.
जो ये टॉर्क कैलकुलेट दिया गया वो इलेक्ट्रोमैकेनिकल टॉर्क हुआ ना सर?
That is, yeah, that is electromagnetic developed torque. No inclusion of any rotational losses and all till this point. After that point, this is mechanical developed torque. After that point, some rotational loss will be there or mechanical loss will be there, but that is generally neglected in gate problems.
Yes, sir. Yes.
Huh. Any other question?
सर अगर कंसीडर लाइक सपोज करते हैं कि सर आर्मेचर रेजिस्टेंस दिया हुआ है, ब्रश ड्रॉप भी दिया हुआ है,
Hmm.
तो मेरा जो टर्मिनल के पास वोल्टेज है और जो करंट है वो इनपुट पावर जो होगा, क्या हम उसको बोल सकते हैं इलेक्ट्रोमैकेनिकल पावर, जो वहां से भी टॉर्क कैलकुलेट कर सकते हैं? वैसे नहीं ना, क्योंकि ड्रॉप भी तो बीच में होगा।
हाँ, इफ अगर करंट वहां पे होगा, देन इनपुट पावर माइनस कॉपर लॉस, दैट विल बी डेवलप्ड टॉर्क, right? Or developed power corresponding to that speed, that will be developed power. If no current is there, I have shown that power flow diagram in, I think, synchronous motor. So let's say electrical power is going on, okay, to develop some mechanical or developed power, which will develop or electromagnetic, okay. So there will be some copper loss due to current. Whatever the load, whatever the fraction of current or load it is operating, that copper loss will be there. After that, some mechanical loss or frictional plus windage, then it will go to shaft. So this is general, very compact power flow that you should remember from motor to load. Right? Any other question? So I guess there are no more problems from this side. So let me move ahead with other problem. Other problem is related to torque speed characteristics of induction motor. And so this problem also appeared in GATE 2014 only. So here we had to find out which torque speed characteristics is stable or unstable, right? So load torque is given, motor torque characteristics are also drawn. We had to find which characteristics or which point is stable or and which point is unstable, right? So from first figure, if you see, uh, when motor is trying to catch the load, it is towards attaining the load torque. It could be called in a stable mode. So general formula for this stability, I have written it down. So motor torque variation with a speed should be greater than load torque variation with a speed. Then it should be called as stable. So either you can remember this formula or you can understand this formula. You see that when in this figure at point P, what is happening? When a speed is increasing, or let's say it is in this manner. This is TL, this is a speed, and blue one is TM. So at this point, the slope of motor torque with variation with a speed like dTm by dn, that speed is higher than dTL by dn, right? Because the slope of dTL by dn is 0 at P and dTm by dn is increasing. So if it will be higher, it will be stable. Let us see at Q point.
डायरेक्शन ऑफ स्पीड राइट टू लेफ्ट ना सर?
Sorry, sorry.
स्पीड का डायरेक्शन राइट टू लेफ्ट होगा ना सर, क्योंकि उस समय तो एन एस जीरो होगा, फिर इधर एन एस इक्वल टू है ना, इंक्रीज करेगा ना लेफ्ट साइड में। स्पीड तो लेफ्ट साइड में बढ़ेगा ना सर, राइट साइड में नहीं ना?
Okay.
जो आप और
Okay.
एरो ले
Okay. 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 So this you are saying that a speed in that direction. Okay.
जो आपने बनाया ऐसे ये हॉरिजेंटल ये टॉर्क स्लिप
Okay.
कैरेक्टरिस्टिक्स
Okay.
उसमें यस
So
यस
this would be negative speed, this would be positive. Doesn't matter. Do you feel any difference would be there? This is
सर
negative.
यस
NS induction motor, if you remember.
यस
You remember induction motor characteristics? It is similar to that, right?
यस यस
Uh,
ओके
So, any confusion you can ask, like maybe I am maybe wrong also. So I am assuming that the speed in this direction or this direction, x-axis is the speed axis, and motor torque is increasing, and it is trying to approach. It will increase load torque, and if motor torque is greater than load torque, then the system is in acceleration mode, or load angle you can say it will increase, but after some point if it reaches at optimal point it should decrease, otherwise it would go out of super synchronous speed, or the angle would be out of phase more than 90. So generally swing, if you have might have studied in swing equation, its characteristics is also similar to that, and at q the dtm by dn is less than dtl by dn, because at q dtl by dn is 0 and dtm by dn is negative. So which is bigger? I guess dtl by dn is bigger, and if this slope is higher than this, then the motor would be unstable. So q point would be unstable and p point would be stable here. Similarly, for this case, in B, any confusion in this?
No, sir.
Okay, fine. So if no, then let us take this point R and S. At R, at R, motor torque slope is a straight line. So let us say something. This angle is theta 1 slope. But if you take tangential angle, this is more. This slope is higher than theta 1. So at R point, dTm is less than dn. dTm by dn is less than dTl by dn. So what would be it? Which case? Stable or unstable? Can anybody
Unstable.
guess? Sorry?
unstable
Ah,
Unstable.
fine. Thanks. So it would be unstable. At S also, what is happening? The reverse is happening, right? dTl by dn is lesser than dTm by dn. So it would be which case? Stable or unstable? At S?
unstable
Fine, thanks. It would be stable. So just you need to identify the slope between them, which is higher, and if motor torque is higher than load torque at any point, that is considered as stable. So in GATE generally, this type of problem came, and if you want to, there are more theory behind it, more concepts behind it, but I don't think that is worth it to discuss it here because that is not necessary. This would help you. So any Doubt in this?
सेकेंड फिगर में जो मेरा पी है वो स्टेबल रीजन में आ रहा है और जो क्यू है वो अनस्टेबल रीजन में आ रहा है, तो ऐसे नहीं बोल सकते हैं पी जो है स्टेबल होगा और क्यू जो होगा अनस्टेबल।
हाँ, तो पी ये स्टेबल ही है, क्यू अनस्टेबल।
मतलब ऐसे भी देख के बोल सकते हैं बिना डेविड ये डीटीएम बाई डीएन करते हुए वैसे भी तो देख सकते हैं ना कि मेरा पी जो है स्टेबल रीजन में आ रहा है तो मेरा पी जो पॉइंट होगा वो स्टेबल होगा।
हाँ, मतलब how you can say that P is stable just by looking at it? Do you have any idea?
नो।
Okay, one way that you see that motor torque is trying to approach load torque, right? Till P and beyond P also. Beyond P, it is exceeding the load torque, but till P, it is trying to catch up with load torque. So if torque is trying to catch up with load torque, it could be called as a, a stable region, right? And at Q point, motor torque is trying to get lower than load torque. So after that, it is not possible that it would again rise and it will again attain the load torque. So it that is not sure, right? Until and unless some motor power is given. So that's why it is just my perspective. I may be wrong. So by looking at it, you can say in that manner it is stable or unstable. So you were thinking in that manner, or do you have any other idea? Okay, fine, no issue. So you make sure that you do not make mistake or you do not apply any intuition in gate exam. Otherwise, it will cost some negative marks as well. So you just try the formula, apply the formula if you know, and you get the correct answer. Hmm. So moving ahead with parallel operation of transformer here, I had written some point. See, why do we operate two transformers or more transformers in parallel? First, first and foremost thing is to avoid faulty conditions. If some fault is appeared in transformer 1, then transformer 2 should be able to cater the load, right? It should not trip down, all loads are connected. So first objective is this fault. And second objective is to maximize the efficiency, right? So let's say our load demand is something like 1000 watt. Let's say our load demand is 1000 watt, and transformer 1 is providing us 800 watt, and transformer 2 is providing 200 watt. And rating of both the transformers are same. So, and in second scenario, I will give you one another scenario where same 1000 watt is catered by T1 of 500 watt and T2 of 500 watt. So which scenario do you think would be more efficient? This is case 1, this is case 2. So which
केस
scenario?
टू।
Okay,
केस टू।
case 2. Anybody else? Okay, so Abhishek, you tell me why case 2 you have chosen.
बिकॉज क्योंकि अगर ट्रांसफार्मर वन जो फर्स्ट केस में अगर T1 खराब होता है तो मेरा T2 सिर्फ 200 ही वाट देगा, लेकिन ट्रांसफार्मर T2 खराब होता है तो T1 800 वाट देगा, तो वो मेरे लिए सही है। लेकिन सेकंड केस में देखेंगे कि बोथ केस में मेरा सेम ही पावर ट्रांसफर करेगा। अगर
Mhm.
T1 भी खराब होता है T2 मेरा 500 वाट देगा, जब T2 खराब होता है T1 भी सेम पावर देगा सर, तो वो मुझे एफिशिएंट लगा सर फर्स्ट केस टू।
Okay, fine. You are around that. But the other suggestion would be like operate the multiple transformers at same power level. Why so? You know the condition of maximum efficiency, right? So when both transformers have same rating, so why to underutilize one and why we are overutilizing one? if both have, let's say, 500 watt of rating or 600 watt of rating, so if both the transformer is catering same power, then it should be considered as more efficient condition. If, in other words, if let's say this power had been dropped out to 500 watt, okay. Now, if the rating of both the transformer is also 500 watt, so we should not do that, cater it 250 watt from one and 250 watt from other. It is not a efficient way. If this transformer or any grid has the capability of producing or transferring or generating some level of power, we should up, the maximum efficiency appears at full load, right? If you drop the loads, but that much power was generated, right? Some grid had generated, let's say, 1 megawatt of power, and our load demand is reduced, so that is very inefficient way. So we should generate so much of power that much is required. In that condition, it would be efficient, right? So we should keep in mind that we should cater that much power only, how much is required. You got it? Did I messed it up, or you got the point?
Means case one is more efficient.
No, 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 not. Earlier case 2 was more efficient. That you were correct, but the region was wrong. Later, if we reduce the power level, then we should operate one. If one transformer is able to cater that much load, then we should remove the burden from the second transformer, right? So that was my whole crux.
Yes.
Huh. So these two conditions were there, and some conditions, some necessary conditions, and some desirable conditions are mentioned in textbooks. You can refer for that, and those conditions are, first condition is voltage rating must be same. Excuse me for a second. So I was saying that voltage rating must be same, and I mean by voltage rating with magnitude as well as phase, so that if let's say two transformers are connected in parallel. So what will happen if voltage between both the transformers are different? Any guess?
Circulating current.
Yeah, fine, perfect. Circulating current will flow among the transformers. So the purpose of transformer is not to supply the current to each other. It will create additional losses, and there is no point of using one transformer to feed the other transformer. The purpose of transformer is to supply the power to the load, right? So for that purpose, we should always avoid circulating current, and for that only we maintain same voltage rating with angle or phase, so that if let's say magnitude is equal but phases are not equal, then power would flow from higher angle to lower angle, that we have seen in synchronous machines. So these conditions we should always maintain. First is voltage rating. Polarity should be same. Again, if voltage and angles are same but polarity are opposite, then current would be 2 times of voltage difference divided by resistance. So again, high circulating current will flow, and phase sequence must be same, again for the same region, and phase shift I mentioned. So these were some necessary conditions. Let us talk about desirable conditions. So desirable conditions are that uh, the rating of transformer should be directly proportional to the load. So that's what I was trying to convey earlier. Uh, Whatever the load, rating should be proportional to the load. Let's say transformer 1 has 1000 watt, transformer 2 has 500 watt, and load is 750 watt. I am doing just a scalar calculation here. So the power that should be supplied from transformer 1, S1 divided by S2, should be proportional to load 1 by load 2. Let's say I have divided load into two parts. So here transformer 1 should supply, that should be 500, 500, and transformer 2 should supply 250. The rating should be proportional to the load. So we will see in problems how these are done. I have taken only a scalar one. If we will do some vector analysis, you will get better idea, right? And the another desirable condition is to have equal power factor among both the transformers. So that will help us in distributing equal power. If the power factor between two different transformers which are connected in parallel, if the power factor are equal, then we do not bother to do phasor analysis, right? It will be a scalar. Let's say one transformer is supplying 1 pu of power with 36.86 power factor lagging, and another is also supplying of current this much. So the load power would be, we can just add it a scalar, right? 36.86. So that is the benefit of doing equal power factor. So these two conditions are desirable. If you have it, it is very good. Otherwise, you can manage. So this is the circuit in which manner the parallel operation is done generally. So this is EA, ZA. This is transformer 1 has some series resistance and leakage reactances. And in second transformer, EB with connected with series resistance and leakage reactance. And both is catering a single load. This is load. So how the current would be supplied from transformer 1 to load and transformer 2 to load. So this is a current division formula which you can apply, and from these two expressions you can arrive SA, like load load catered by transformer 1 would be equal to SL. uh, Let me drop it down, sorry. Huh. So if you just multiply it with terminal voltage, you will get VIL conjugate ZB. So you see, load KVA rating of transformer should be proportional to load, and it will come in inversely proportional to the impedance. So SA is inversely proportional to ZB, and SB is inversely proportional to ZA. Do you guys have any problem in understanding this expression? I assume that you have read already, but again, if you have any confusion in this expression, I can explain in detail. So SA by SB is equal to ZB by ZA conjugate. So any issue in this expression, because this is very, very important expression. From this
No, sir.
expression, sorry.
No doubt.
Okay, thanks. Huh. So if no issue, then we will move ahead with some problems as well. And from this condition, we can arrive to an important conclusion, that is ZA per unit should be equal to ZB per unit. To satisfy this condition that I was saying, KVA rating should be directly proportional to load. हाँ,
KVA rating of transformer A to transformer B is equal to impedance of transformer B by impedance of transformer Y conjugate से.
हाँ, okay, Y conjugate. You see, here I did this IB is in terms of IL, IA in terms of load current, right? If
तो
you
ये
if you try to find the KVA rating of SA or how much power is catered by transformer A, that should be multiplied. What is the formula of KVA or apparent power? V into IL conjugate, right? You know, VI conjugate,
only VI नहीं sir.
KVA, apparent
K
power, what is it?
VI conjugate complex powers. Yes.
Right. In synchronous machines also we have seen this. So VI conjugate it should be, right? Here,
Yes.
till this point, I haven't talked about conjugate terms, but after that part, I need to deal it in terms of load. So in terms of apparent power, I am multiplying it with V and I am doing conjugate with IL or IA. So SA would be V into IA conjugate, right? So
सर तो ट्रांसफार्मर ए जो है कितना केवीए रेटिंग सप्लाई करेगा रोड पर तो वो होगा टर्मिनल वोल्टेज जो रोड के क्रॉस वोल्टेज है और उसके क्रॉस जो करंट होगा उसका प्रोडक्ट ना सर कॉम्प्लेक्स तो
yes,
फिर कौन तो फिर कॉन्जुगेट क्यों लगा है इस
okay, okay. See,
डायरेक्टली आपको देखते समय वो देखेंगे सर तो जो सपोज करते हैं कि रोड के क्रॉस में वोल्टेज है V2 एंगल कुछ एंगल होगा सर
mm-hmm.
और जो ट्रांसफार्मर ए है सर तो जेडे के क्रॉस कुछ करंट फ्लो कर रहा है जो कि आई ए है सर
Okay.
आई ए समथिंग एंगल
हाँ,
तो जो ट्रांसफार्मर ए जो है रोड को
हम्म,
कितना केवीए सप्लाई करेगा तो जो
हम्म,
टर्मिनल के क्रॉस वोल्टेज होगा वी एंगल कुछ एंगल इनटू जो करंट फ्लो करेगा आई ए मैग्नीट्यूड समथिंग एंगल वो दोनों का प्रोडक्ट होगा
हम्म,
सिंपली
हम्म.
तो फिर यहाँ पर भी तो कॉन्जुगेट अब लगा है तो मैं कंफ्यूज हो गया हूँ सर
Okay, okay, fine. That will be cleared in problem also, but I will try to clear the confusion here as well. Let us see this terminal voltage, it has magnitude of V angle 0. Okay, let us assume, or V.
यस
I am telling it as a V, right? What would be the KVA rating of transformer 1? You just tell me KVA rating of transformer 1 in terms of VI conjugate or VI.
तो सर ये केवीए ये हम ये बोल रहे हैं सर जो ट्रांसफार्मर ये जो है
Hmm,
रोड को कितना केवीए सप्लाई करेगा
hmm,
तो जो मैग्नीट्यूड ऑफ बी एंगल जीरो है वो
hmm.
प्रोडक्ट होगा बी मैग्नीट्यूड ऑफ बी एंगल जीरो इनटू आई ए मींस आई ए का मैग्नीट्यूड इनटू एंगल समथिंग वो बस सिंपली
And you are saying that it should not be IA conjugate.
नो सर
VIA conjugate is wrong according to you. Okay, no issue. We will clear this confusion in problem solving session. I think 25 minutes or more. So we will switch to problem soon. Let me just finish this portion. So uh, for time being, you Abhishek just assume that this is correct. Just for time being, if it is wrong, we will deal.
ओके सर
Uh, uh. So uh, is means KVA rating of transformer that is catered to load is inversely proportional to its impedance that is derived from simply current division rule. And after doing current division, I am just multiplying with IL or IA. Let's say uh, how much KVA rating was catered by transformer 1? That is I have taken V into IA conjugate. That should be equal to V into IA conjugate. I have calculated here IA. I can easily do IA conjugate multiplying with conjugate to all other terms. Okay. So I have come to this conclusion. SA into ZA is equal to SB into ZB. So after that, how I am coming to this conclusion, ZAPU divided by ZBPU. Okay. So I am just dividing with voltage. Let's say Who's someone has turned his mic, I guess. Swani, you could turn off your mic. Okay, I will do it. Thanks. So, yeah, I was saying and that how I am coming to this conclusion. SAZA divided by VA a square, or let's say V square, SB ZB by V square. If I am dividing these terms by voltage square on both sides, it should be equal, right? And V square by SA can be, if I will say it as rated and SA rated, similarly SB rated. So V square by S, V square by KVA, that should come out to be Z base. If you remember the concept of per unit.
भी रेटेड जो होगा V1 रेटेड होगा ट्रांसफार्मर ए
हाँ,
ट्रांसफार्मर 1 का
that I was about to tell, but since you have told us here, if you consider it as a V1 for this transformer A and for V2, okay, so
Yes.
it will come out to be ZA base is equal to ZB divided by ZB base, which will lead us ZA per unit should be equal to ZB per unit. Okay, fine.
Yes.
Uh, So now we will see some problems. I have that Abhishek has shared with me. Let me open that. Where is it? So you guys can read the problem. Before this, I should take the problem. So let us start with a basic problem. Then we will go in percentage terms. So this is also the problem shared by Abhishek. Anubhav, are you there?
No, sir.
Okay, fine. So in this problem, it is said that two single-phase transformers are connected in parallel to supply a load of 1000 kVA at zero point 0.8 power factor lagging. So load is 1000 kVA, 0.8 power factor lagging. Now, transformer 1 is rated at 400 kVA, this one, and has a per unit equivalent impedance of 0.01 plus J 0.06 per unit. So this is per unit impedance of transformer 1. Again, transformer 2 has rating of 600 kVA and per unit impedance of 0.01 plus j 0.05. So you can see here impedances are also different, rating of transformers are also different. So how these transformers would cater the load, that would be interesting to see at the end. So we know SA is equal to SL into ZB divided by ZA plus ZB conjugate. Any doubt in this formula or should I derive it? That will take just 1 minute. If you say, I can derive it here. Any doubt in this formula?
No, sir.
Okay, fine. Okay. So, huh. Now, there are two approach. Whichever would be convenient to you, you pick that. Okay. We can calculate the power fact. We can calculate the power factor of first transformer, right? That I will do it. That is 0.06 tan inverse of 0.06 divided by 0.01. So its power factor angle is 0.1. Think no, tan inverse 0.06 divided by 0.01. So that is 80.53 angle. 80.53. This is phi 1. Again, phi 2. Again, phi 2 is tan inverse 0.05 divided by 0.01. That would come out to be 78.7 degree. Okay. Now, if you do not want to deal in conjugate terms, so let me take that case first. If you do not want to deal with conjugate terms, if this is lagging, you just take it as the manner when current is written in lagging terms, right? So if lagging angle of current, let's say if current is written as lagging power factor, we write in this manner. I hope you are agree with it. In same manner, I will write, huh?
Sir,
Yeah, sure.
such power factor was a cos of tan inverse 0.06 by 0.01.
Hmm.
तो वहाँ एंगल मेरा 89.5 था.
You are saying that value is wrong.
Yes, sir. Tan
The first one
0.06.
0.06 divided by 0.01, that is 80.53 coming. That phi angle, not cos phi, I am saying. Is it wrong? Hmm?
Tan 0.06 by 0.01 is
Okay,
89.
okay. Let us not go into the values. Okay, we should just focus on constant concept as of now. If values are here and there, we will manage at the end, right? So let us. Uh, I have calculated it here. It should not be wrong. You verify it. If it will be wrong, we will see it in next session as well. No issue. So I hope it is not wrong. And here the angle is 78.7 degree. So actually, I was trying to make my point how to deal with conjugate terms, how to remove the concept of conjugate when you are dealing with parallel operation of transformer. So you should, if you write in proper terms, how it should be written. So SA will be written like that. What is that? So SA would be written as SA angle 80.53, right? Let us take the value.
minus
That I am about to say. This is the rating of SA. When I do not want to deal in conjugate terms. If you want to do it in original manner or whatever the perfection is there, you can write it as 400 minus 80.53. Hmm. Huh. Yeah, minus should be here. So this is just to make our approach convenient, okay? And this is the original thing. Like how do you
so in the
write? This is original,
see
this is convenient. What are you saying?
जो फर्स्ट केस में से ऐसे वो एक्चुअल है जो सेकंड में वो कॉन्जुगेट है
No, no. The first one is real. This is conjugate actually, essay conjugate, but we don't write essay conjugate anywhere, right? So why I am writing in minus and how I am saying it is convenient? Because if you write current in terms of power factor, if it is lagging, you write I angle minus something. If let's say 36.86 degree of lagging, you write 5 angle minus 36.86. So here also you should not put lot of brain here. You should just write 400 angle minus 80.53 degree if it is lagging power factor for transformer 1. Okay. So first I am dealing with convenient approach should, which should not make you commit any mistake during the exam. And in second case, I will take the what is general approach and how people deal with that. So let me move ahead with it. Okay. Let me just and similarly I can write SB. How I can write SB in convenient form? 600 angle minus 78.7 degree. Okay, I am just writing lagging as negative. Generally, it is not the same, but I am just writing here lagging as negative, leading as positive. Okay, now we had to calculate the load on each transformer. So, SA formula would be this. Similarly, I can write about SB. SB is equal to SL ZA divided by ZA plus ZB. So here I am also removing the conjugate terms. Okay, if I am writing in this term. Now we know load that is 1000 kVA and load power factor 0.8, that is minus 36.86. I can write like this. I can write the load in this manner. I have written SA in this manner. I have written SB in this manner. So I am just going to complete the calculation. SA would be SL 1000 angle minus 36.86 ZA 0.01 plus 0.06. It is given in per unit. You are saying something?
ये जो जेडे उससे per unit में like यहाँ पे जेडे जो सो एक्चुअल ना उसे means R plus J into X
Hmm.
ohmic value ना होगा से
Yeah, correct. Fine. You are correct. But see, if ohmic value would be divided by base value here as well and here as well, so it would again come into per unit, right? So in fraction, it doesn't matter you write in per unit or actual value. If you are writing somewhere uh, which is isolated, there you should care. But here you should not care whether it is per unit or actual value, because both are in fraction. If you divide it by base or if you multiply it with base, let's say I am talking in per unit. This is per unit for ZA. And here I will add, let me add 0.01 plus J 0.06 plus 0.01 plus J 0.05. Okay. So this is per unit I have done ZA divided by ZA plus ZB. Sorry, ZB divided by ZA plus ZB. If I multiply with Z base here also and here also, it will come in actual format. No issue.
सर जो ट्रांसफार्मर टू का है उसका बेस वैल्यू तो अलग होगा सर।
Sorry, your voice is not coming properly. Can you
हाँ
speak?
सर, जो ट्रांसफार्मर टू का जो बेस वैल्यू होगा वो डिफरेंट होगा।
That is for different case. That is for different case, not here. If you want same power factor, then you can apply that. Right? Here I am not doing ZA per unit is equal to ZP per unit. If ZA per unit by ZB per unit is written either that in actual or any per unit, that doesn't matter. But if you write ZA per unit is equal to ZB per unit, then it does matter. But if you divide it by base, and here in problem it is given per unit, it means they have considered same base. If in problem anything is given in per unit, then they would have considered same base. This is for
तो
our
यहाँ पर
convenience. हाँ,
जो वैसे पर यूनिट है ट्रांसफार्मर वन का उसको बेस जेड बेस से मल्टीप्लाई कर रहे हैं, जो जेड बेस होगा वो ट्रांसफार्मर वन का होगा ना सर। तो फिर मेरा ओमिक वैल्यू जो होगा ट्रांसफार्मर वन का देगा, लेकिन वही ट्रांसफार्मर टू का मेरा दिया हुआ है और ट्रांसफार्मर वन का बेस वैल्यू मल्टीप्लाई कर रहे हैं, तो फिर तो वहाँ मुझे ओमिक वैल्यू तो नहीं देगा, डिफरेंट वैल्यू देगा सर।
base
तो मैं
value
बोल
in problem is single one. If any problem is given with per unit, then you have to consider same base value for entire data in voltage, in kVA, everywhere.
ओके
There is nothing mentioned explicitly that base value for this transformer is this and base value for another transformer would be that. Okay, as long as this condition is fulfilled, you can go ahead with same base value. Fine.
यस
Okay, perfect. So that's why we were not bothering about base value here, and we should not bother about base value until and unless they are isolated. In fraction, we can take any value. If it would have been given in actual value, you could have been used that. In other case, you can just move ahead with per unit value.
सर
So
हम यहाँ पे ये नहीं बोल सकते ट्रांसफार्मर वन का पर यूनिट वैल्यू दिया हुआ उसका जेड बेस जो होगा ट्रांसफार्मर वन का ये नहीं बोल सकते हैं।
no, you can't say until it is mentioned explicitly.
ओके
Huh. So now you have to calculate it, and just calculation is there. So if you just multiply it with something, 1000 into, let's say, minus 36.86 into 0.01 plus 0.06 I divided by 0.02 plus 0.11 I, and that would come out to be 0.544 plus J 8 0.008. Okay, so again we will convert it into phasor format. So 1000 angle minus 36.86, and I have to take the magnitude 0.544 square plus 0.008 square, and that would come out to be 0.544 only with angle 008 divided by, and okay, so 0.842 degrees something is coming. You should verify it. If it would be wrong, we can discuss again. So that would come out to be 1000 into 544. So that should be 544 angle minus 36.86 plus 0.842. So that is minus 36 only. So this would be the load of transformer A here, and transformer A is delivering 544 kVA and 36 degree of lagging power factor angle. Again, if I verify, or I should calculate SB in same manner. So SB can be done in same manner, SL ZA divided by ZA plus ZB. And
We can simply SA plus SB is equal to SL
you
in
can do
phases.
that. You can do that as well. That is
बट
perfect.
मैग्नीट्यूड डिफरेंस इन दिस केस एसे का जो वैल्यू है 544 वो बुक में 642 दिया हुआ है मैग्नीट्यूड अलग है लेकिन एंगल सेम है
Okay, there might be some calculation mistake then, I guess. You should just verify it and
ओके
I will again see. But concept would be more or less same. Okay. So that's the purpose of telling this. So here you do not need to bother about conjugate because many places you will see conjugate or no conjugate. Somewhere they are removing conjugate from impedance only. Somewhere they are removing conjugate from these terms. So just for convenient, you stick to this approach. You try to solve two, three problems which had appeared earlier in GATE exam. And if you face any problem, we will again take up these problems in next class. Fine?
यस मैं एक बार फिर से इसको सॉल्यूशन करूंगा सर कि आपके
Ha,
पास से
sure. And you tell me whether you are getting the correct answer or not. Okay. So any other problems? And I do not want to discuss another approach, which includes conjugate thing. Why? Because if you, and this should be our like general approach, we should just focus on a single method so that you do not get confused when questions will arise in exam. So this is very important to avoid the confusion. So if some problem would have lot of approaches, then you will be thinking for first 2 minutes which we should move with which approach. That happens in network also. In network basic, you know so many approach, Mace, Norton, Thevenin, and whatnot. But at the end of the day, whichever approach in you are confident, that should be your tool. So that's why I am not going to discuss that conjugate thing. You should also try to solve all the problems based on parallel operation with this approach, and I think you should be able to get the answer. Here, some mismatch might be due to calculation mistake, but you check it. If some mistake would be from my side, we will discuss in next lecture. Fine, so I am thinking we should wind up now. If any final doubt is there, I will take it.
जो दूसरा क्वेश्चन है वो नेक्स्ट क्लास में डिस्कस
Sure, we will discuss in next class then.
दूसरा सेशन भी स्टार्ट हो चुका है
Okay, then you may go ahead and you can join that section. Fine,
थैंक
thank you very much, everyone.